In the early 1940s, the world was burning. The United States faced a new kind of war, one that stretched across entire oceans. The Pacific was vast, and Japan's homeland sat thousands of miles beyond the reach of existing bombers. To strike deep into enemy territory, America needed something entirely new – a bomber that could fly higher, faster, and farther than anything ever built before. In 1940, Boeing engineers gathered in secret rooms to design a machine that defied the limits of its time. Their goal was simple – create a flying fortress that could cross the Pacific, deliver its payload, and return safely without refueling, without escorts, and without mercy. The result was the B-29 Superfortress, the most advanced aircraft of World War II. It was pressurized, electrically controlled, and equipped with remote-operated gun turrets, technologies no other bomber in the world possessed. But progress came at a cost. The project consumed over $3 billion, more than the Manhattan Project itself. Thousands of engineers, technicians, and factory workers labored day and night in America's industrial heartlands to bring this vision to life. By the time it was ready, the B-29 wasn't just a plane. It was a symbol of American engineering dominance, a flying city of metal and fire born from urgency and ambition. Its birth marked the beginning of a new era in warfare, one where the sky itself became a global battlefield.
When war erupted across the Pacific, geography became America's greatest enemy. Japan's empire stretched over thousands of miles, from the Asian mainland to tiny islands scattered across the ocean. To reach it, American bombers would have to fly distances never attempted before. Early aircraft like the B-17 and B-24 were powerful, but they simply couldn't go far enough. Their range was limited, their payloads small, and their crews exhausted long before reaching Japan's industrial heart. In the dark months after Pearl Harbor, American strategists faced a grim question. How could they strike back when their targets lay beyond the horizon? The answer lay in range. If a bomber could fly higher, faster, and farther than any before it, it could bypass the ocean, hit the enemy where it hurt most, and still make it home. The U.S. Army Air Forces issued a daring demand: build a bomber with a range of over 5,000 miles, capable of carrying 20,000 pounds of bombs, and flying at 30,000 feet, well above enemy defenses. It was a dream that bordered on impossible. No engine could handle such strain. No airframe could carry that much fuel. No crew had ever flown such distances. But America was willing to try, because whoever mastered long-range flight would control not just the Pacific, but the future of air warfare itself. Designing a bomber to cross the Pacific was not just engineering, it was an act of imagination under pressure. Engineers at Boeing and the Army Air Forces sketched planes that looked impossible on paper: enormous wings to carry fuel, streamlined fuselages to slice the thin air at high altitude, and systems that would let crews survive and fight thousands of miles from any friendly runway. The starting problem was simple and brutal: fuel versus weight. To carry enough gasoline for a round trip to Japan meant adding tanks, which added weight, which required more lift and stronger wings, and that in turn demanded more powerful engines. The entire design became a house of cards, where every gain created a new problem. Boeing answered with size and innovation. The new bomber would have a vastly larger wing and an airframe strong enough to hold unprecedented quantities of fuel. It would be pressurized, so crews could live and fight comfortably at 30,000 feet. It would use remote-controlled gun turrets, a radical move that reduced drag and gave gunners better protection. tricycle landing gear, an extended bomb bay, and redundant systems, all aimed to make long missions survivable. But the plan hinged on reliable power plants. Engineers pushed engine technology to the brink, seeking motors that could push a massive bomber to high altitude for hours on end. Every prototype flight exposed new limits, cooling problems, vibration, and the terrible, recurring risk of engine fires. Test pilots and mechanics met these failures with relentless fixes, mounting them into production changes overnight. Designing the plane also meant building an industrial miracle. Entire towns were repurposed for mass production, thousands of workers trained on new assembly techniques, and supply chains stretched to bring rare parts together. Blueprints multiplied into jigs, and jigs multiplied into assembly lines as the Superfortress moved from drawing board to flight line. The result was a machine born from compromise and courage. Not perfect, but capable. It could carry the fuel, the men, and the bombs far enough to cross the Pacific, altering strategy and forcing enemies to reckon with a new kind of reach. Designing a bomber to reach Japan was less about a single breakthrough than 1,000 small battles won in factories, test fields, and drafting rooms. The quiet campaigns that made strategic distance suddenly, terrifyingly possible.
In World War II, range wasn't just a performance number, it was survival. Every mission was a gamble between fuel, weight, and distance. Crews knew that running out of fuel meant more than failure. It meant disappearing into the sea or crashing behind enemy lines. The bombers of the early war years, like the B-17 and B-24, were technological marvels of their time, but they were designed for Europe, not the Pacific. Their tanks could barely carry enough fuel for round trips of 2,000 miles. Japan, however, was more than twice that distance from the nearest American base. Engineers faced a brutal equation. To fly farther, a bomber needed more fuel, but more fuel meant more weight, and more weight meant less room for bombs, the very reason the plane existed. Add to that the thin air at high altitude and the constant drag of propellers, and even a small increase in range demanded huge engineering sacrifices. The Pacific Theater made these limits painfully clear. Missions over Japan required bombers to fly from bases in China, a logistical nightmare. Every gallon of gasoline had to be flown in before it could be used to fly out. For every ton of bombs dropped, 12 tons of fuel had been consumed just to deliver it. This impossible math forced a revolution. Designers began exploring new wing designs to hold more fuel, lighter materials to reduce drag, and even experiments with in-flight refueling, an idea that sounded like science fiction at the time. Fuel became the invisible weapon of the air war, the deciding factor in how far a nation's power could reach. And it was this challenge, above all others, that gave birth to a machine built not just to fight, but to endure. The B-29 Superfortress would be that answer, a bomber born from the endless struggle between distance and endurance, built to turn fuel itself into victory. As aircraft pushed farther and faster during World War II, one question refused to go away. What if a plane never had to land? The idea of refueling in midair wasn't new, but in the early 1940s, it was still little more than a daredevil fantasy. Pilots had experimented with it as far back as the 1920s, dangling fuel hoses between two biplanes while crews leaned out of open cockpits with metal cans and funnels. It worked just long enough to prove the concept and then usually ended in disaster. But war changes what's possible. The Pacific Theater made fuel the true currency of power, and suddenly the concept of aerial refueling went from stunt to necessity. Military planners began asking, could a bomber be met halfway across the ocean by another plane carrying fuel? Could they trade endurance for airspeed and keep the war machine in motion indefinitely? Engineers at Boeing, the Air Transport Command, and a small British company called Flight Refueling Ltd. began running quiet experiments,
Some tried crude grappling line systems, where one aircraft would trail a cable and the other would snag it mid-air before pumping fuel through. Others proposed the tanker-bomber pair linked by hoses through the sky, a dangerous ballet at hundreds of miles per hour. Every test was risky. Pilots fought turbulence, static sparks, and the constant fear of collision. A single mistake meant both planes going down in flames. Yet each attempt brought them closer to something extraordinary, the ability to extend a mission not by minutes, but by continents. Though these first systems were unreliable and rarely used in combat, they lit a spark that would soon grow into one of aviation's greatest innovations. The dream of a plane that never landed, once a fantasy, was beginning to take form, drop by drop, hose by hose, in the skies above a world at war.
By 1941, Boeing faced an impossible demand: build a bomber unlike anything the world had ever seen. It had to fly higher than fighters, carry more than any bomber before it, and travel thousands of miles across the Pacific and back. The task was so ambitious that even Boeing's own engineers weren't sure it could be done. In their Seattle design rooms, the team began to tear apart the rulebook of aviation. They didn't just make the B-17 bigger, they reimagined what a bomber could be. The breakthrough came from integration, not imitation. Every part of the B-29, the engines, fuselage, wings, even the gun systems, was designed to serve a single goal: range and endurance. The wings were vast and slender, designed to hold massive fuel tanks and create the lift needed for long-distance flight. The fuselage was the first ever pressurized in a combat aircraft, allowing crews to operate comfortably at 30,000 feet above the worst of enemy flak and weather. And then came the biggest leap: the Central Fire Control System. Instead of manning exposed gun positions, gunners operated remote-controlled turrets using periscopic sights linked by analog computers. It was a technological marvel, decades ahead of its time, that reduced drag and made the bomber faster and safer. But Boeing's true breakthrough wasn't just the design, it was the process. The company created massive new production plants in Wichita, Kansas and Renton, Washington, mobilizing tens of thousands of workers. Entire sections of the aircraft were built separately and shipped for final assembly, an industrial ballet synchronized by precision and urgency. Each test flight brought new challenges: overheating engines, hydraulic leaks, mechanical failures, but the vision never wavered. Boeing refined, rebuilt, and tested again until the Superfortress finally lived up to its name. When the B-29 took to the skies in 1942, it wasn't just another bomber. It was the embodiment of American ingenuity and industrial might. A flying fortress that could cross oceans, deliver devastation, and still come home. It was more than an aircraft. It was proof that the limits of flight could be broken, and Boeing had just rewritten the definition of what was possible in the air. At the heart of the B-29 Superfortress lay its greatest gamble, the Wright 3350 duplex Cyclone engine. It was one of the most powerful piston engines ever built: 18 cylinders, twin turbo superchargers, and over 2,200 horsepower. On paper, it was a masterpiece, the muscle that would lift the B-29 higher, faster, and farther than any bomber in the world. But in reality, it was a ticking time bomb. The R-3350 was rushed into production before it was ready. Every ounce of power pushed the engine's limits. It ran hot, dangerously hot, and the complex turbochargers that gave it altitude performance often caused more problems than they solved. During early test flights, engines began to fail violently. Mechanics watched in horror as cylinders overheated, oil lines burst, and flames erupted from the nacelles. Sometimes the fires spread so fast that crews had only seconds to bail out. Pilots began calling it the world's best one-engine bomber. The issue was heat management.
The B-29's tightly cowled engines trapped air around the cylinders, cooking them from the inside. Wright engineers added baffles, larger cooling fins, and new alloys, but none of it fully solved the problem. Field crews worked around the clock, improvising fixes on the flight line, sometimes literally wrapping engine parts in metal foil to reflect heat. In the Pacific, the danger was constant. Long missions over water left no room for error. A single engine fire could mean a crew lost forever in the ocean. Yet the R-3350's power was unmatched. It gave the B-29 the climb, the speed, and the range that no other bomber could achieve. So they flew, despite the risk. Thousands of airmen took off knowing their engines might betray them, but the mission always came first. By the end of the war, improved versions of the R-3350 finally stabilized. The lessons learned in blood and fire would shape every large engine that followed, from the B-50 to the early jet age. The R-3350 was both a triumph and a tragedy, the engine that made the Superfortress possible and the flaw that nearly doomed it. It was a reminder that in the race to conquer the skies, innovation always comes with a price.
The B-29 Superfortress was not just a bomber, it was a flying fuel tank with wings. To cross the vast distances of the Pacific, it needed to carry more fuel than any aircraft of its time. Every mission began with a single question: how far can we go before the tanks run dry? Inside the B-29's enormous wings were 7 self-sealing fuel tanks capable of holding roughly 7,000 gallons of aviation gasoline. Fully loaded, that fuel alone weighed more than 21 tons, nearly half the plane's total takeoff weight. And yet, it still wasn't always enough. A typical long-range mission from the Mariana Islands to Japan, over 3,000 miles round trip, could drain nearly every drop. Pilots watched their fuel gauges drop with a kind of quiet dread, knowing that a headwind, a detour, or one miscalculation could mean ditching in the open sea. Every gallon mattered. Crews often stripped out non-essential equipment to save weight. Bomb loads were adjusted by the weather. Even the altitude of flight was planned to balance engine efficiency against fuel burn. On some missions, the B-29's range was stretched to its absolute limit. Crews reported landing with less than 100 gallons remaining, just minutes from flameout. The aircraft's engines had to be throttled back carefully because sudden bursts of power could double fuel consumption in seconds. The sheer volume of gasoline required was staggering. A single squadron of B-29s could burn through 100,000 gallons of fuel in one night. In forward bases like those in China, that fuel had to be flown in, often by other aircraft, across the Himalayas just to keep the bombers in the air. The B-29's massive fuel capacity was both its strength and its curse. It gave the United States the reach to strike deep into enemy territory, but it also revealed the limits of even the most advanced piston engine bomber. It was this relentless thirst for fuel that inspired a new dream. If bombers could somehow refuel in the air, then range would no longer be measured in miles, but in imagination. When the United States turned its eyes toward Japan, it faced not just an enemy, but an ocean. The Pacific was the largest battlefield on Earth, a vast blue expanse stretching thousands of miles in every direction. For the men who had to fly across it, distance was the deadliest weapon of all. From Hawaii to Tokyo was over 4,000 miles. Even the nearest Allied bases in China or the Marianas lay thousands of miles from Japan's industrial core. No existing bomber in 1942 could make the journey, strike a target, and return safely. The airfields were too far, the ocean too wide, and the fuel too precious.
For planners in Washington, this wasn't just a technical challenge. It was a strategic nightmare. The U.S. could build ships, train men, and produce bombs, but none of it mattered if they couldn't reach the enemy. The Pacific was an invisible wall separating America's power from its purpose. Early attempts to solve the problem bordered on desperate. Smaller bombers were launched from aircraft carriers, like in the Doolittle raid, a one-way mission fueled more by courage than practicality. Others tried operating from Chinese bases, supplied through treacherous hump flights over the Himalayas, each gallon of fuel costing multiple gallons just to deliver. The only real answer was endurance, a bomber that could take off from distant islands and still have the legs to cross the ocean, hit Japan, and make it home. This demand shaped every line of the B-29 Superfortress. Its massive wings, its immense fuel tanks, its high-altitude engines, all were designed for one purpose: to conquer the Pacific's endless reach. Yet even with the B-29, range was a razor's edge. Missions often pushed the limits of fuel and human stamina. Pilots flew for 16 hours straight across a void of water where a single mechanical failure meant death. The Pacific distance problem redefined how America built its bombers, its bases, and its strategy. It forced innovation, inspired risk, and ultimately gave birth to the concept of global air power, the belief that no target on Earth was beyond reach. In solving the distance problem, the B-29 didn't just shrink the Pacific. It changed the scale of war itself.
Even as the B-29 Superfortress proved its dominance across the Pacific, one truth remained. No matter how much fuel it carried, distance was still its greatest enemy. Engineers began to ask a radical question. What if a bomber could refuel while flying? What if range no longer depended on the size of its tanks, but on the coordination of the skies? The idea wasn't new, but turning it into reality was something else entirely. In 1944 and 1945, as the war neared its end, both American and British engineers quietly began testing ways for aircraft to transfer fuel in midair. The goal was simple: extend the reach of bombers and reconnaissance planes beyond the limits of any runway. The first experiments were crude, improvised, and incredibly dangerous. Two aircraft would fly in close formation, often just 30 feet apart, while one trailed a cable or hose toward the other. Pilots had to maintain perfect position while turbulence tried to tear them apart. Static electricity, sudden gusts, or a single wrong movement could turn both planes into fireballs. British engineer Sir Alan Cobham's company, Flight Refueling Ltd., pioneered one of the first practical systems, a grappling line method. A receiver aircraft would snag a trailing hose, reel it in, and connect it to its fuel intake. It worked, sometimes, but in wartime conditions, reliability mattered as much as bravery. Across the Atlantic, American engineers at Boeing and Wright Field took notes. They began modifying surplus bombers, including B-29s, into early flying fuel tankers. These aircraft experimented with a simpler hose-to-hose connection, using pumps to move fuel directly from tanker to receiver. Each success, each failure brought new data. Test crews risked everything to prove that two machines could meet in the sky and share life through a thin line of fuel. Though these early tests never reached large-scale deployment during World War II, they planted the seeds of a revolution. Within a few years, the same concept would evolve into the KB-29, the world's first operational tanker, and change air power forever. Mid-air refueling began as an experiment, a daring test of nerve and physics, but it hinted at something bigger, a future where bombers would no longer be bound by oceans, fuel tanks,
or even the curvature of the Earth. As engineers searched for a safer, more reliable way to transfer fuel in midair, one elegant idea emerged: the hose and drogue system. It was simple, aerodynamic, and for the first time, practical enough to work beyond controlled test flights. Instead of two aircraft trying to connect solid cables or grappling lines, the new system used a flexible fuel hose extended from the tanker's wing or fuselage. At the end of that hose was a small, basket-shaped cone called the drogue, designed to stabilize the line in the air. The receiving aircraft would extend a probe, guiding it carefully into the drogue to create a secure connection. Once linked, fuel would flow through the hose under pressure, keeping both planes airborne for as long as the tanks allowed. It was a delicate dance, one that required absolute precision. The two aircraft flew just meters apart, often buffeted by turbulence, their pilots relying on tiny corrections to stay locked together. But compared to the dangerous grappling line systems of the past, it was a revolution in control and safety. The concept had its origins in Britain. In 1949, engineers at Flight Refueling Limited, led by Sir Alan Cobham, perfected the method using modified Lancaster bombers and Gloucester meteors. For the first time, a jet aircraft was refueled in midair using this system, proving that the technology could handle higher speeds and greater altitudes. The United States took notice. Soon, the technique was adapted to American aircraft, including modified B-29s and KB-29 tankers. These early trials refined the equipment, pumps, and procedures that would later be standard on modern refueling aircraft. The hose and drogue system offered flexibility. Any suitably equipped plane could be topped up mid-flight, from fighters to bombers to patrol aircraft. It made the dream of global air operations suddenly attainable. This breakthrough wasn't just about distance, it was about freedom. No longer did bombers need to plan around fuel stops or island bases. With refueling, they could fly anywhere, stay aloft for hours, even days, an ability that reshaped the very definition of air power. The hose and drogue concept turned imagination into engineering, and engineering into dominance. It was the moment when the sky stopped being a limit and became a runway that never ended.
While the hose and drogue method proved effective, it wasn't perfect. It worked well for smaller, lighter aircraft, but heavy bombers like the B-29 Superfortress needed to take on thousands of gallons of fuel quickly. The drogue system's slower flow rate and limited stability at high altitudes made it inefficient for such massive aircraft. So American engineers began searching for a better way. Their answer was the flying boom, a bold innovation that transformed midair refueling from a dangerous stunt into a precise science. Developed in the late 1940s by Boeing and the U.S. Air Force, the flying boom replaced the flexible hose with a rigid telescoping tube mounted on the tail of the tanker aircraft. At the end of the boom was a nozzle that could plug directly into a receptacle on the receiving plane. The key difference was control. The boom could be steered by a boom operator who lay prone in the tail of the tanker, guiding the connection with a set of small aerodynamic fins. Once locked in, fuel could flow at astonishing rates, up to 5 times faster than the hose and drogue system. For the first time, large bombers could refuel efficiently and safely, even in rough weather or at high speed. Early tests were carried out with modified B-29s and B-50s serving as both tankers and receivers. The sight was extraordinary. 2 4-engine giants flying in formation, joined by a narrow boom carrying life between them. Crews described it as refueling at arm's length, with just a few feet separating disaster from success. These experiments laid the foundation for a revolution in global air strategy. The flying boom proved so reliable that it became the standard system for the U.S. Air Force, leading directly to the KB-29, KC-97, and eventually the legendary KC-135 Stratotanker. What began as an experiment born from the B-29's limitations would become a defining feature of modern air power, the reason bombers, fighters, and even stealth aircraft could circle the globe without ever touching the ground. The early boom refueling tests showed that technology could conquer not just gravity, but endurance itself. From that moment on, the sky wasn't just a place to fly, it was a place to live.
When the Second World War ended, the dream of a bomber that never needed to land didn't fade, it evolved. The lessons learned from the B-29's massive range and its constant hunger for fuel gave rise to a new kind of aircraft, one not built to bomb, but to feed those that did. Enter the B-29, the world's first true flying fuel tank. Born from modified B-29 Superfortresses, the B-29 was the first operational tanker designed specifically for aerial refueling. Its bomb bays were stripped out and replaced with fuel tanks and powerful pumps. Long hoses ran through its fuselage and wings, connecting to either the hose and drogue system or later the flying boom. The aircraft that once carried destruction now carried endurance, transforming how wars would be fought in the air. The first B-29s took to the skies in the late 1940s, during a time when global tension was shifting from open war to Cold War. The United States Air Force needed to keep its strategic bombers, the B-50s and soon the B-47s, airborne for missions that could stretch across continents. The B-29 made that possible. Refueling in midair was no longer an experiment, it was a mission. Pilots and boom operators trained to fly within feet of each other, connecting machines that weighed over 100,000 pounds each. Every successful link was a triumph of skill and nerve. Every drop of fuel that passed between the two aircraft represented hours of extra range and global reach America had never known before. The B-29's influence was immediate. It allowed bombers to patrol the edges of the Soviet Union, stay aloft longer, and strike farther than ever imagined. It also paved the way for a new generation of purpose-built tankers, the KC-97, and later the KC-135 Stratotanker, aircraft that would make continuous flight a cornerstone of American air power. The B-29 wasn't glamorous and it never dropped a single bomb, but it changed the world just the same. It took the same airframe that symbolized World War II's fury and turned it into the backbone of Cold War endurance. The first flying fuel tank proved that the real power in the sky wasn't just firepower, it was the ability to stay there.
If the B-29 was the machine that made endless flight possible, then its crews were the ones who made it real. But mastering mid-air refueling wasn't just about flying, it was about precision under pressure. For bomber and tanker crews alike, the idea of connecting two massive aircraft in flight was terrifying at first. Imagine piloting a 100,000-pound bomber edging closer and closer to another aircraft until the wingtips seemed to scrape the sky. A moment's hesitation could mean disaster, a collision, a fire, or both planes tumbling from the clouds. Training began on clear days over empty stretches of desert and ocean. Crews practiced formation flying for hours, learning to hold their position within just a few feet. The refueling crews learned a new language of hand signals, lights, and radio codes, subtle gestures that kept two giant aircraft moving as one. The boom operators, often lying face down in the tail of the B-29, became specialists in calm focus. They guided the long refueling boom like a surgeon's instrument, using small control surfaces to fly the boom into place. Every connection required timing, coordination, and trust. The receiving pilot had to hold perfectly steady while the tanker adjusted for speed, altitude, and wind. Early training was full of close calls. Booms snapped, hoses tangled, and more than one crew found themselves bathed in leaking aviation fuel. But each failure taught valuable lessons about speed, communication, and the delicate balance between control and chaos. Over time, the crews became experts. They learned to refuel at night, in storms, and eventually at high altitudes. By the early 1950s, tanker and bomber crews were conducting routine mid-air refueling missions, something that seemed impossible just a few years earlier. For the men who flew them, it wasn't just a technical achievement. It was a bond, a literal lifeline between two machines and two crews, trusting each other in the most unforgiving environment on Earth. The training was relentless, the danger real, but every successful refueling proved one thing: the sky could now be conquered not in miles, but in hours and endurance.
Mid-air refueling may have been a triumph of engineering, but it came with a terrifying truth. There was no room for error. Two massive aircraft, flying just meters apart, carrying thousands of gallons of high-octane fuel. One spark, one gust of wind, one mistake could turn the sky into an inferno. In the early days of refueling, accidents were alarmingly common. The hose and drogue system could whip violently in turbulence, sometimes striking the receiving aircraft. Hoses snapped, connectors jammed, and fuel often sprayed freely into the slipstream, a deadly hazard if it ignited. The flying boom system, while more stable, carried its own dangers. Boom operators had to fly the rigid refueling boom with delicate precision, keeping it perfectly aligned. If the pilot of the receiving aircraft moved too fast or too slow, the boom could break apart, puncture a fuselage, or tear into a wing. More than once, the violent separation of the boom caused fires, mid-air explosions, or catastrophic loss of control. One misjudged maneuver could destroy both aircraft, the tanker and the receiver, in an instant. Crews trained endlessly to minimize the danger. But even with experience, accidents still happened. Fuel leaks could saturate the tanker's fuselage, making it a floating bomb. Static discharge or an electrical spark could ignite vapor trails. And when refueling at night or in bad weather, pilots often lost visual contact, relying on instruments and instinct alone. For those inside the aircraft, the stress was enormous. Boom operators described their work as flying with a match over a pool of gasoline. Pilots spoke of the eerie silence as two engines hummed side by side, knowing that one wrong move could mean death for both crews. Every successful refueling was a balancing act, a fragile dance between trust, timing, and technology. And every accident reminded them that while the sky could now be conquered by endurance, it demanded respect with every drop of fuel that crossed between wings. The dangers didn't stop innovation, they defined it. Each tragedy pushed engineers to design safer connections, stronger hoses, and better communication systems. Out of those lessons came the highly reliable refueling procedures still used by the Air Force today. Mid-air refueling gave America global reach, but it was earned through courage, precision, and sometimes sacrifice.
Before mid-air refueling, a bomber's range was a prison built by its own fuel tanks. Every mission was a calculation: how far it could go, how long it could stay, and whether it would have enough fuel to come home. But when aerial refueling became a reality, those limits vanished almost overnight. For the first time, long-range bombers like the B-29 and later the B-50 and B-47 could fly missions that once seemed impossible. They could take off heavy, carrying full bomb loads with only partial fuel, climb quickly to altitude, and then refuel in the air, extending their range by thousands of miles. What once required forward bases across the Pacific could now be done from the continental United States. A bomber could launch from Kansas, refuel over Alaska or the ocean, and strike targets on the far side of the world, all without ever landing on foreign soil. This changed everything about strategic warfare. The United States no longer needed to rely on distant bases vulnerable to attack. Refueling turned the sky itself into a mobile base, one that could shift and adapt as missions demanded. During the early Cold War, this new capability became the cornerstone of Strategic Air Command, SAC. Bombers on nuclear alert could stay airborne for half a day, refueled by KB-29s or KC-97s waiting in pre-planned zones. This meant America could strike anywhere on Earth or stay ready to strike at a moment's notice. Refueling didn't just extend flight time, it extended strategy. It allowed for round-the-world flights, continuous air patrols, and missions limited only by the endurance of the crew and the strength of the machine. In simple terms, refueling turned the bomber from a regional weapon to a global one. The B-29 had started the idea, a plane built for distance, but aerial refueling made that dream truly limitless. The effect was profound. No longer was range a barrier. The sky belonged to those who could refuel in it.
Aerial refueling didn't just extend missions, it rewrote the rules of global air power. Before refueling, strategy was dictated by geography. Bombers needed bases near their targets, fighters needed carriers or forward airfields, and entire wars were fought over small strips of land that could host an airbase. But once aircraft could refuel in midair, the map itself lost its power. Suddenly, range was no longer a limitation. It was a choice. A bomber taking off from the United States could reach anywhere on Earth with 1 or 2 refuelings. Fighter escorts, once bound to short-range hops, could now travel alongside bombers across oceans. Entire fleets could operate from a single continent, striking targets continents away. This changed how nations thought about warfare. Instead of building massive overseas bases, the U.S. could project force from home. Refueling tankers became airborne lifelines, quietly supporting bombers, reconnaissance planes, and later, jet fighters. During the Cold War, refueling defined strategy itself. With the threat of nuclear conflict ever present, the Strategic Air Command, SAC, maintained bombers in the air 24/7, continuously refueled, constantly ready. The ability to stay aloft indefinitely meant that deterrence no longer depended on geography, but on endurance and readiness. In crises like the Berlin Airlift, the Korean War, and later Vietnam, refueling allowed U.S. aircraft to respond instantly from great distances. It made air power truly global, flexible, fast, and unpredictable. By the 1950s, aerial refueling wasn't a secret advantage anymore, it was a necessity. No major mission, no bomber force, no global operation could function without it. Every major air strategy since, from the Cold War nuclear patrols to modern stealth bomber missions, has relied on the same principle first proven by the B-29's descendants. You don't have to land if you can refuel. Refueling changed the very concept of the sky, from a barrier to a bridge. It turned nations into global powers, extended wars into continents, and made endurance, not distance, the ultimate measure of strength. From the Pacific of World War II to the jet age and beyond, aerial refueling didn't just make planes fly farther, it made the world smaller.
The B-29 Superfortress was built for distance, and during its service, crews pushed that capability to its limits.
In its standard configuration, the aircraft could fly about 3,000 to 3,500 miles without refueling, depending on its bomb load and altitude. But through careful planning, favorable winds, and stripped-down equipment, some missions stretched far beyond those figures. One of the longest recorded B-29 flights occurred in 1946, when a modified aircraft completed a non-stop flight of over 8,000 miles using auxiliary fuel tanks. The mission was designed to test the limits of range for potential global operations and to study the effects of extreme endurance on both crew and engines. During the final stages of the Pacific War, extended-range missions from Tinian to Japan and back regularly exceeded 3,000 miles round-trip, often with minimal fuel reserves upon return. These operations highlighted how little margin existed for error. Every gallon mattered, and weather or headwinds could mean the difference between home and ditching at sea. Post-war experiments with KB-29 tanker support and in-flight refueling prototypes began pushing the B-29's effective range beyond 10,000 miles, though most of these were test flights, not combat operations. Such missions proved that global reach was technically achievable, but only with refueling and rigorous coordination between crews. The lessons learned from these long flights were critical in shaping the next generation of strategic bombers, particularly the B-50 and B-47, which were designed with aerial refueling as a standard capability. The B-29's record-setting flights demonstrated the upper limit of piston engine endurance and set the stage for the transition to jet-powered global operations.
As World War II faded and the Cold War began, the skies became a new battlefield, one fought not with bombs, but with endurance and secrecy. Behind closed hangar doors and in remote airfields, the U.S. Air Force began conducting classified refueling experiments designed to push human and mechanical limits beyond anything attempted before. These secret tests weren't just about extending range, they were about strategic invisibility. The goal was simple: keep America's bombers in the air long enough to strike anywhere on Earth, or to stay hidden for days at a time, ready to launch at a moment's notice. In the late 1940s and early 1950s, modified KB-29s and B-50s took part in long-duration flights under the supervision of the newly formed Strategic Air Command, SAC. Many of these missions were officially logged as training flights, but in reality, they were refueling endurance tests, designed to see how long a bomber could remain airborne with a steady chain of tanker support. Crews flew in strict radio silence, often over isolated routes stretching across the Arctic or the Pacific, where Soviet radar couldn't easily track them. Refueling rendezvous points were coded and changed daily. Tankers operated in pairs, leapfrogging each other to keep the bombers supplied with fuel, a technique that became known as airborne relay refueling. Some of these secret flights lasted more than 60 hours, pushing both aircraft and airmen to exhaustion. Engines overheated, oxygen ran low, and crews battled fatigue in freezing high-altitude cabins. The slightest mistake during refueling could mean catastrophic loss. Yet the missions continued, quietly proving that no target was too far and no mission too long. The age of continuous flight had begun, forged not in daylight parades, but in the lonely night skies of Cold War secrecy.
The end of World War II didn't mark the end of the B-29's story. It marked its rebirth. The lessons learned from the Superfortress in combat and the urgent new demands of the Cold War pushed Boeing's engineers to create something stronger, faster, and longer-lasting. The result was the B-50 Superfortress, a plane that looked like the B-29,
but under its skin was almost entirely new. At first glance, the B-50 seemed like a simple upgrade, a B-29 with new engines and better equipment. But in reality, over 80% of its structure was redesigned. The airframe was strengthened with new alloys to handle greater weight and higher altitudes. The wings were reinforced and slightly swept to improve stability. The tail fin was enlarged to help control the aircraft at greater speeds and heavier fuel loads. The biggest change lay in its heart, the Pratt & Whitney R4360 Wasp Major, a 28-cylinder radial engine producing more than 3,500 horsepower each. These powerful engines gave the B-50 a top speed of nearly 400 miles per hour, almost 100 miles per hour faster than the B-29, and allowed it to climb higher and carry more fuel or bombs over greater distances. But the transformation wasn't just about performance, it was about endurance. The B-50 was designed from the start to work with aerial refueling systems. Many were modified to act as either tankers or receivers, using the early flying boom method perfected with the KB-29. This made the B-50 one of the first bombers capable of truly intercontinental range, with no dependence on overseas bases. In 1949, a specially modified B-50 named Lucky Lady II proved what this new capability meant to the world. Taking off from Fort Worth, Texas, and refueled 4 times in the air, the Lucky Lady II completed the first nonstop flight around the world, a 23,452-mile journey that took 94 hours and 1 minute. It wasn't just a test, it was a message to every nation watching. America now had the power to strike anywhere, anytime. The B-50 Superfortress bridged the gap between the piston-driven age of the B-29 and the jet-powered future of the B-47 and B-52. It was the final, refined evolution of a design that had started as a desperate wartime gamble, now transformed into a symbol of global reach and Cold War dominance. The Superfortress had become truly super, not because it flew farther, but because it proved the distance itself was no longer a limit.
The B-29 Superfortress didn't just change the face of bombing. It laid the foundation for a new kind of aircraft entirely, the airborne tanker. Every lesson learned from the B-29's fuel-hungry engines, long-range missions, and early refueling experiments directly shaped the creation of the KC-97 Stratofreighter, the plane that would define aerial refueling for an entire generation. After World War II, the U.S. Air Force faced a new reality. Its bombers were flying farther and faster than ever, but the tankers supporting them, modified B-29s and B-50s, were still limited by the same piston engine technology. The success of the KB-29 as a tanker proved the concept of aerial refueling, but the Air Force needed something bigger, more reliable, and purpose-built for the job. Boeing engineers turned once again to what they knew best, the Superfortress. They took the B-29's proven wing and tail design and combined it with a new, much larger fuselage borrowed from Boeing's C-97 Stratofreighter, itself a cargo transport derived from the B-29 family. The result was the KC-97, an enormous, high-wing aircraft with the heart of a bomber and the body of a freighter. Inside, the KC-97 carried multiple fuel tanks, high-capacity pumps, and the now standard flying boom system, refined from the KB-29's early designs. Its pressurized cabin allowed crews to operate comfortably at high altitudes during long-duration refueling missions, a luxury the B-29 never had. The connection between the two aircraft was unmistakable. The KC-97's engines,
4 powerful Pratt & Whitney R-4360s, the same ones that powered the B-50, gave it the strength and endurance to serve alongside jet bombers like the B-47. The tanker's cockpit, control layout, and much of its structure carried the unmistakable DNA of the B-29's wartime engineering. Operational by the early 1950s, the KC-97 became the backbone of Strategic Air Command's global reach. It refueled bombers and fighters from Europe to Asia, serving as the silent partner in nearly every major Cold War air operation. Without the B-29's pioneering design and the refueling trials born from its limitations, the KC-97 would never have existed. The Superfortress didn't just inspire it, it evolved into it. From carrying bombs to carrying fuel, from destruction to endurance, the B-29's legacy lived on in the KC-97, the aircraft that kept the sky open and the bombers flying for decades to come.
When World War II ended, America faced a new kind of conflict, one that wouldn't be fought with armies clashing over territory, but with air power and deterrence. The atomic age had dawned, and the nation that controlled the skies would control the peace. In March 1946, the U.S. Army Air Forces created a new organization, the Strategic Air Command, or SAC, to oversee long-range bombers capable of carrying nuclear weapons anywhere in the world. Its purpose was clear: to keep America's nuclear strike force ready at all times. At its heart was a single powerful idea: global reach through constant readiness. SAC would maintain bombers on alert, trained and prepared to launch at a moment's notice, day or night. The newly developed B-29 Superfortress and later the B-50, B-47, and B-52 would form the backbone of this airborne deterrent. But the concept of global readiness introduced a daunting challenge: how to keep bombers in the air long enough to reach their targets and still come home. The answer was aerial refueling. In the early days of SAC, modified KB-29 tankers worked alongside bomber crews to test continuous flight operations. These were not just exercises, they were rehearsals for nuclear war. Crews practiced long-range missions, refueling rendezvous, and polar navigation routes that would allow them to reach targets deep inside Soviet territory. From bases spread across the US and Europe, SAC aircraft created a web of constant motion, tankers and bombers weaving invisible routes around the globe. To the world below, they were unseen, but to those in the know, they represented the ultimate deterrent, a strike force that could appear anywhere without warning, fueled by precision and endurance. Under the leadership of General Curtis LeMay, SAC became more than just a command. It became a culture. Crews trained to perfection, maintaining the highest readiness standards in military history. Missions were timed to the second, refueling procedures drilled until instinctive. Every pilot, operator, and mechanic understood that their readiness could prevent catastrophe or deliver it. The creation of the Strategic Air Command marked a turning point in world history. It was the moment when air power became not just a weapon, but a strategy, one built on the lessons of the B-29 and on the revolutionary promise of mid-air refueling. From that moment on, the U.S. Air Force no longer needed to fight for airspace. It owned it.
The B-29 Superfortress was born in the fires of World War II, but its influence stretched far beyond the piston age. Its design, endurance, and the refueling innovations it inspired became the blueprint for the jet-age tankers that would dominate the Cold War skies. By the early 1950s, aviation was changing fast. Jet bombers like the B-47 Stratojet and B-52 Superfortress were entering service. Sleek, high-altitude aircraft that could fly faster and farther than any propeller-driven plane before them. But they had one major weakness: they burned fuel at an incredible rate. The piston-powered tankers that had supported the B-29 and B-50, the KB-29 and KC-97, simply couldn't keep up. They were too slow and couldn't climb to the same altitudes as the new jets. During refueling, jet bombers often had to slow down and descend, burning extra fuel just to meet their tankers. It was a temporary fix, not a long-term solution. But Boeing had already solved problems like this once before, with the B-29. The Superfortress had pioneered high-altitude pressurization, efficient fuel management systems, and long-range structural design, all of which became essential technologies in the next generation of tankers. Taking those lessons, Boeing engineers developed a new concept: a jet-powered tanker that could match the speed and altitude of modern bombers. The result was the KC-135 Stratotanker, first flown in 1956, and its DNA traced directly back to the B-29. The KC-135's flying boom system was an evolution of the refueling gear first tested on modified B-29s. Its pressurized cockpit, streamlined fuselage, and emphasis on efficiency and endurance were all principles proven decades earlier by the Superfortress. Even its mission, to keep bombers flying across oceans and continents, was the same one the B-29 had pioneered, only now powered by jets instead of pistons. In essence, the B-29 didn't just inspire the KC-135, it taught the world how to build it. The Superfortress had shown what was possible: global range, endurance through refueling, and a seamless blend of technology and human precision. The KC-135 became the direct successor to that vision, refueling bombers, fighters, and reconnaissance aircraft for over half a century. And even today, the U.S. Air Force still relies on the same core refueling concepts first proven in the B-29's era. From the rumble of pistons to the roar of jet engines, one truth remained: the plane that never landed gave birth to the tankers that never stopped flying.
By the dawn of the Cold War, a bold dream had quietly become reality. A bomber that could fly anywhere on Earth, strike any target, and return home without ever touching the ground. What began with the B-29 Superfortress had evolved into something far greater, a new kind of warfare, where endurance mattered more than speed and refueling turned the impossible into routine. The concept was simple in theory, but revolutionary in practice. Through aerial refueling, bombers could stay aloft indefinitely, sustained by a network of flying tankers, the KB-29, the KC-97, and eventually the KC-135. Each tanker acted as a lifeline, extending missions not by miles, but by days. This idea gave rise to the ultimate symbol of strategic dominance, the bomber that never needed to land. In the late 1940s and 1950s, U.S. Strategic Air Command tested the concept relentlessly. B-50s and later B-47s circled the globe, refueled multiple times by their airborne partners. The most famous of these was Lucky Lady II, the modified B-50 that completed the first nonstop flight around the world in 1949, a journey made possible only through midair refueling. The mission proved what strategists had dreamed of since the B-29's creation. A bomber could now strike any target, anywhere, without depending on bases, runways, or borders. The sky itself had become the base. For years afterward, SAC maintained bombers on near-continuous airborne alert. Refueled by tankers waiting over the ocean, these aircraft could remain ready for action 24 hours a day, a constant reminder to America's rivals that its reach was endless. It was an extraordinary transformation. The same airframe that once struggled to reach Tokyo from the Pacific Islands now had inspired machines capable of circling the planet. The B-29's legacy wasn't just its bomb load or its wartime victories. It was the idea it carried, that flight itself could be sustained indefinitely, that the sky could become a permanent frontier. In the end, the B-29's true triumph wasn't in what it destroyed, but in what it created. A new age of endurance, global reach, and machines that could fly forever if the fuel kept flowing. It was, quite literally, the plane that never needed to land.
During World War II, crossing the vast Pacific Ocean wasn't just a matter of courage. It was a battle against physics. The distances were enormous, the weather unpredictable, and fuel capacity was the one thing even the most advanced aircraft couldn't stretch far enough. For the B-29 Superfortress, designed to strike Japan from remote island bases, the ocean was both the battlefield and the barrier. Every mission had to be calculated down to the gallon. A headwind, a navigation error, or a delay could mean the difference between returning home or running out of fuel hundreds of miles from safety. But the war had proven one thing. Air power could only be as global as its range. So engineers, strategists, and pilots began searching for ways to maintain flight endurance over oceans, to keep bombers airborne for hours, even days, without needing to land. The first solutions were simple but risky: external fuel tanks, stripped-down payloads, and delicate balancing acts between weight and range. The B-29's enormous wings held over 9,000 gallons of fuel, yet even that wasn't enough for the kind of reach the U.S. envisioned after the war. Then came the breakthrough: aerial refueling. What began as an experimental idea during the late 1940s quickly became the key to mastering long-distance flight. Modified B-29s, turned into KB-29M tankers, began transferring fuel mid-air to their bomber counterparts. It was a dangerous, highly coordinated ballet at thousands of feet above the ocean, but it worked. With tankers stationed at strategic points across the Pacific and Atlantic, aircraft could now hop from one invisible fuel bridge to another, staying airborne across continents and seas. For the first time, the phrase unlimited range wasn't science fiction. It was operational reality. This ability to maintain flight endurance over oceans transformed global strategy. It meant that bombers no longer depended on forward bases. It allowed the U.S. Air Force to project power from home soil to any point on the planet. And it made the ocean, once a deadly obstacle, just another part of the flight plan. The lessons learned from these missions didn't end with the B-29. They became the foundation for Cold War operations, for jet-age tankers, and even for modern aerial logistics. Every time a modern aircraft crosses an ocean nonstop, refueled midair, guided across the globe, it carries within its wings the legacy of those early missions when engineers and aviators first dared to ask, what if a plane never had to stop flying?
When the dream of endless flight became reality, a new challenge emerged, not for the machines, but for the people inside them.
The idea of remaining airborne for days at a time demanded more than engineering innovation. It required redefining what it meant to live and work in the sky. During the late 1940s and early 1950s, U.S. Air Force crews aboard the B-29, B-50, and later B-47 bombers began to push the limits of human endurance. With refueling now possible mid-air, missions could last not just hours, but entire days, stretching across oceans, continents, and time zones. Inside those pressurized aluminum hulls, the world outside became a distant memory. The roar of the engines never stopped. The cockpit lights stayed dimmed to preserve night vision. Crewmen rotated between stations, eating from ration packs and sleeping in short bursts, sometimes on the cold floor, sometimes hunched against their equipment. Fatigue became their invisible enemy. Long missions blurred time. Sunrise and sunset meant nothing when you flew through them multiple times a day. To stay sharp, crews developed strict routines, navigation checks every few minutes, engine readings, radio calls, and log entries that marked the slow passing of the endless sky. For refueling missions, coordination was everything. A slight error in alignment could spell disaster. Crews often spent hours preparing for a single connection, scanning the horizon for the faint glint of a tanker aircraft. When contact was made, the tension was palpable. Two heavy bombers, flying just meters apart, joined by a fragile line of flowing fuel. But beyond the danger and exhaustion, there was pride. These men were pioneers, the first generation to truly live in the air. They learned how to manage food, sleep, hygiene, and morale in an environment that was never meant for comfort, an airborne world of constant motion and thin air. Some missions, like Lucky Lady's Eye's 1949 global flight, lasted more than 90 hours, almost 4 days spent entirely in the sky. When the plane finally landed, the crew staggered out pale and exhausted, but victorious. They had proven that humans could adapt to the sky just as much as the machines they flew. Their endurance laid the foundation for everything that came afterward, from Cold War bomber patrols to modern aerial reconnaissance and long-range surveillance. They had shown that flight wasn't just a means of travel, it could become a way of life. In the end, these airmen weren't just pilots or navigators. They were sky dwellers, men who learned to live where no one was meant to, keeping their aircraft and their nation aloft through sheer discipline and willpower. They didn't just fly missions, they lived them.
The ability to transfer fuel from one aircraft to another, a concept that once sounded like science fiction, became one of the greatest technological leaps in aviation history. It turned bombers into global weapons, patrol planes into sky sentinels, and transport aircraft into flying lifelines. But this didn't happen overnight. The evolution of air-to-air refueling systems was a story of daring experiments, dangerous trial and error, and constant innovation. It all began in the 1920s with crude experiments involving little more than hoses, buckets, and bravery. Two planes would fly dangerously close, and fuel would literally be poured or siphoned between them using handheld hoses. It was chaotic, unreliable, and often deadly, but it proved one vital point: it was possible. By World War II, the idea had grown more sophisticated. With the Pacific Ocean stretching endlessly between bases and targets, the US and Britain began exploring more controlled systems. The first major step forward came with the hose and drogue method, where a tanker trailed a flexible hose ending in a drogue, a funnel-shaped cone that stabilized the line in flight. A receiver aircraft, equipped with a probe, would carefully connect and receive fuel mid-air. It was elegant in its simplicity, but required extraordinary precision from pilots. The hose and drogue became the standard for Navy and smaller aircraft, thanks to its flexibility and relatively lightweight design.
Then came the flying boom, a system born from Boeing's post-war innovation and first tested on modified KB-29 and KB-50 tankers. Instead of a simple hose, a rigid telescoping tube extended from the tail of the tanker, controlled by a dedicated boomer operator. This allowed faster, more stable fuel transfer, perfect for large strategic bombers like the B-47 and B-52. The flying boom system revolutionized air refueling. It could pump thousands of pounds of fuel per minute, cutting refueling time dramatically and allowing operations at higher altitudes and speeds, essential for the new jet age. By the 1950s, the evolution was complete. The hose and drogue for flexibility and fire operations. The flying boom for power and heavy aircraft. Both systems became the backbone of modern aerial logistics. Through the decades, refinements continued. Pressure-regulated valves, automatic disconnects, night vision guidance, and computer-assisted alignment systems. Modern tankers like the KC-135, KC-10, and KC-46 Pegasus now carry multiple systems to service any aircraft in any mission anywhere in the world. From buckets of fuel between open cockpits to automated booms in the stratosphere, the goal has remained the same: to make sure aircraft never run out of sky. The evolution of air-to-air refueling didn't just extend range, it redefined aviation itself. It turned the air into an endless highway and gave humanity something it had never had before: the power to stay aloft as long as it chooses.
The story of modern aerial refueling isn't just about machines, it's about lessons learned the hard way. Every hose that snapped, every failed connection, every near miss in the skies taught engineers and pilots something new. From those lessons came the modern aerial tanker, one of the most vital aircraft in the world today. When the first refueling experiments began with modified B-29s and B-50s, there were no manuals, no computers, and no safety nets. Crews operated by instinct and coordination alone. They learned early that stability, precision, and communication were everything. A small misalignment at 300 miles per hour could destroy two aircraft in seconds. Lesson 1 was control. Early systems like the hose and drogue were flexible but unstable in turbulence. That led to the development of stabilizing drogues, aerodynamic fins, and eventually the flying boom system, which allowed a dedicated operator to guide the refueling probe with precision. Lesson 2 was speed and altitude. Propeller-driven tankers like the KB-29 and KC-97 couldn't match the performance of new jet bombers. This mismatch forced bombers to slow down and lose altitude during refueling, wasting time and fuel. The answer came in the 1950s, the KC-135 Stratotanker, a fully jet-powered refueler designed to operate side by side with the B-47 and B-52. It became the model for every tanker that followed. Lesson 3 was endurance through efficiency. The B-29 missions had shown how critical fuel planning was. Every pound of fuel mattered, not just for range, but for balance and performance. That insight led to innovations in fuel management systems, center of gravity control, and pressure refueling, allowing tankers to carry and transfer massive loads safely. Lesson 4: adaptability. Different aircraft required different systems. Fighters preferred the hose and drogue, bombers used the flying boom. Modern tankers learned to support both. Today's KC-10 Extender and KC-46 Pegasus can switch between systems mid-mission, making them universal refuelers capable of servicing any ally or aircraft type in the air. And finally, Lesson 5 was safety. Early crews faced countless risks. Electrical sparks, turbulence, or simple human error could cause catastrophe. Those experiences drove the development of automatic cutoffs, breakaway couplings, pressure regulators, and redundant hydraulic systems, all designed to make a once deadly procedure almost routine. Together, these lessons turned refueling from a desperate wartime experiment into a precise, dependable science.
every modern tanker flying today, from America's KC-46 to Britain's Voyager and the world's A330 MRTT, carries the DNA of those early B-29 missions. What started as an act of ingenuity and courage became the foundation of global air power. The men who risked their lives passing fuel over the Pacific didn't just keep bombers flying. They built the knowledge and systems that keep modern air forces in the sky every hour of every day. The legacy of those lessons is clear. As long as tankers can fly, the world's reach will never end.
The B-29 Superfortress was more than just a bomber. It was a revolution in distance. When it took to the skies in 1944, it wasn't merely about firepower or altitude. It was about reach, the ability to strike targets an ocean away and still come home. Before the B-29, bombers were limited by geography. They could only go as far as their fuel tanks allowed, forcing armies to fight for every island, every airstrip, just to inch closer to the enemy. But the B-29 changed that equation. Its enormous wings, lightweight structure, and innovative fuel system gave it an unprecedented range, nearly 3,250 miles, far greater than any bomber before it. It was this capability that made the bombing campaign against Japan possible. The B-29 could launch from remote Pacific islands like Tinian and Saipan, reach the Japanese mainland, and return, a feat no other aircraft could achieve at the time. It wasn't just a bomber, it was a bridge across the Pacific. But the true legacy of the B-29's range innovation went beyond the war. It changed how the world thought about air power. It proved that distance no longer defined limits, technology did. Engineers and strategists realized that with enough fuel and eventually the ability to refuel mid-air, the world could be connected through the sky. That realization shaped everything that followed. The B-50 Superfortress, born from the B-29's design, incorporated stronger engines and structural upgrades to carry even more fuel. It became the first aircraft to fly non-stop around the world, thanks to aerial refueling, a direct evolution of the range that the B-29 had pioneered. Then came the KC-97, the KC-135, and the jet-age tankers that allowed aircraft to stay airborne indefinitely. Each of them carried forward the same philosophy that began with the B-29, that the key to dominance in the air wasn't just speed or altitude, it was endurance. Even today, the lessons of the Superfortress live on. Modern bombers like the B-2 Spirit and B-21 Raider and long-range surveillance aircraft that patrol the globe all trace their design lineage to the B-29's focus on efficiency, aerodynamics, and fuel management. Its innovations in range and refueling didn't just change a war, they reshaped the very idea of what an airplane could do. The B-29 taught the world that with the right technology, the sky could be endless. Its spirit endures in every modern tanker, every global bomber, and every mission that crosses oceans without pause. In the end, the B-29 didn't just extend flight, it extended possibility. It was the first aircraft to show that humanity could conquer not just the air above, but the distance beyond.
When the B-29 Superfortress first roared into the skies, no one could have imagined how deeply it would reshape the future of warfare. It began as a bomber, but it became the foundation of a new kind of air power, one where the sky itself became home base. The phrase, "the plane that never landed," wasn't just poetic, it was prophetic. Through the innovations it inspired, longer range, aerial refueling, and non-stop endurance, the B-29 made it possible for aircraft to stay aloft for as long as fuel, crew, and courage could last. Before the B-29, flight had boundaries. Bombers were chained to their runways, their range limited by geography and logistics. Every mission required nearby bases, forward outposts, and complex supply lines. But the B-29 and the tanker technology that followed cut those chains forever. When mid-air refueling became a reality, the world map changed overnight. No longer did a nation's air force depend on where its bases were, only on where its tankers could reach. A single bomber could now cross oceans, circle continents, and deliver power anywhere on Earth. This concept transformed not just tactics, but global strategy. It gave birth to the Strategic Air Command, a force that kept nuclear-armed bombers flying around the clock during the Cold War, always ready, always airborne. It allowed reconnaissance planes to patrol the edges of rival nations, spy aircraft to photograph distant territories, and rescue planes to reach any ocean on Earth. Even more profoundly, it inspired the world's first true global air infrastructure, fleets of tankers, waypoints, and protocols that made endurance a normal part of flight, from the KC-135 Stratotanker in the 1950s to the KC-46 Pegasus today. Every aerial refueling system carries the DNA of that original B-29 innovation. And it wasn't just military power that changed. The very idea of continuous flight, staying in the air indefinitely, influenced the design of long-range passenger jets, scientific flights, and even the planning of space missions. The notion that distance was no longer a limit began right there, with a bomber built for a war that ended up shaping a century. In the end, the plane that never landed didn't just extend range, it extended imagination. It proved that dominance in the air wasn't about how fast you could fly, but how long you could stay. It turned the sky into a battlefield, a home, and a highway all at once. And long after the last B-29 disappeared from active service, its legacy still flies. Every time a tanker connects with a bomber in the clouds, every time a plane crosses an ocean without stopping, and every time humanity dares to push the edge of endurance just a little farther. The B-29 didn't just change how planes flew, it changed what air power meant forever.